Hello everyone. What we are going to do today is the conservation of mass lab. Okay, so we had vinegar and baking soda. This is the ones that y'all did together, so I'm actually going to do the ones on the back first. Magnesium and hydrochloric acid. Now, you will see that we have magnesium. Here is my magnesium. It's just these little pieces of metal here. My hydrochloric acid, this is what it looks like. It looks like water, but I promise you, it is just hydrochloric acid. Okay. And then what we should get afterwards is this magnesium chloride and this hydrogen gas. Now, because it's a gas, what's going to happen is you're going to get bubbles, and the bubbles are going to try and leave. The problem is these bubbles actually weigh something. So if we let the bubbles leave, it's going to look like we had a decrease in mass. In reality, we did not. Okay. So what I'm going to do is I'm going to measure the mass of my equipment because I can't do this chemical reaction without using this equipment. Now, I have this lovely thing called an Erlenmeyer flask, and I have a balloon. This balloon, what it's going to do is it's going to capture all of the gas that we have here. So I'm going to weigh everything first. Let's hope this balloon doesn't actually fall down into. Okay. The mass of my Erlenmeyer flask and my balloon is 188.0 grams. So I'm going to use that for this one. I'm also going to use that for this one because carbon dioxide is a gas. So I'm going to say the 188.0 grams for my equipment here because it's going to be the same equipment. All right, so here we go. What I'm going to do first is I'm going to measure out a little bit of hydrochloric acid because I have to get the mass of the equipment and the reactants. Remember, the reactants are at the beginning of the chemical equation, not at the end. The end are the products. So I need to get everything contained, but not actually react. So I'm going to show you how to do that. First, I'm going to pour some of this hydrochloric acid in here. Just a little bit. That's probably plenty right there. Okay. And now what I need to do is I need to get this magnesium, these two strips of magnesium in here, but not react. So what I'm going to do is I'm actually going to put it inside the balloon. So I'm just going to put the magnesium inside the balloon just like that. And then I'm going to stretch it over the mouth of the Erlenmeyer flask to look just like this. Maybe I'll get that a little bit better. Okay, something like that. Okay, so, yeah. Now what we're going to do is I'm going to weigh everything. Okay, I have 262.6 grams to begin with. Now to get it to react, I'm going to set this off to the side, and I'm going to let the magnesium fall in. So you see it there, you see the little bubbles forming. There's one piece right here. There's the other piece right over here. I'll give it a little shaky shake. Okay, now, make this a little taller. Oh dear. We'll see. Okay, you can probably hear it bubbling. You can kind of see some steam in there because this is, it does release some heat. I can definitely hear the bubbles forming. And look, the balloon's starting to blow up a little bit. Okay, this is why we had to capture the gas because it's going to bubble away. So, waiting for everything to disappear. Now, the experiment that I did earlier, it really like blew up where the balloon was actually standing up. But the reaction has stopped. There's no more magnesium in there. So I'm going to weigh everything again. There it is. It's the same exact number. I'll scoot it over so you can see it. 262.6 grams. Okay. Now your job is going to be to find the mass of the reactants alone and the mass of the products alone. So what you're going to do with that is you're going to take this number, the mass of the equipment and the reactants, and subtract the mass of the equipment from it. Going to do the same thing for the products. All right. So there you go. Next one I'm going to do, I'm going to fold this so you can actually see it. We're going to do aluminum nitrate and sodium hydroxide. Now, if you look here, boom, 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 I do not see any gas that's being formed. So as a result, I don't actually have to use a balloon for this reaction, okay? But because both of these things are liquid, I'm going to have to use 2 separate test tubes to keep them separate, weigh everything together, and then pour one into the other and weigh it again. Okay, so that's what I got here. Let me set that right there. First, I need to get the mass of the equipment. Okay, so first thing here. Everything's all over the place. It looks like exactly. I'll take this up so you can see. When I look at the scale, it's exactly 180.0 grams. All right, now I need to pour the liquid in there. Okay, these are my 2 liquids. Okay, this is my sodium hydroxide, and this is my aluminum nitrate. So if I were to sit here and balance out this formula, I would have a 3 in front of this and a 1 in front of this. So that means I have to use 3 times the amount of this for this guy. Okay, so I'm going to go ahead and measure out 15 milliliters. There's not enough little graduated cylinders here. Okay, I'm going to measure out 15 milliliters of this sodium hydroxide. Okay, I'm just using a pipette. I'll show you after I'm done here. Almost there. Okay, so there's my 15 milliliters. You can see it kind of. There it is. Okay, looks like water, right? Okay, what I'm going to do is I'm going to pour it into one of these test tubes. Okay, I'm going to do the same thing with my aluminum nitrate, but instead of using 15 milliliters, because I only needed to use 1/3 of it, I'm only going to use 5. And there's my 5. Okay, and pour it in here. Okay, so I've got my 2 liquids separate. Now I need to weigh everything together. Okay, my mass is exactly 200.5 grams. Okay, now I'm going to mix these 2 together. Now what you're going to see is something kind of cloudy. It's going to look like lemonade pulp. All right, and that is that solid that forms. We call that a precipitate. So here we go, pouring it in. Okay, I'm going to let it sit there for a second, and you'll see that it kind of looks a little pulpy. Well, maybe you will. Okay, you can see the little pieces floating around in there. Kind of looks like pulp, like orange juice pulp. Kind of looks a little chunky. That is the precipitate. So now I'm going to weigh both of these again, even though I have nothing in this one, because that was part of the original equipment. And as you can see here, it's exactly 200.5 grams again. Great, this is looking pretty good. So again, your responsibility is find the mass of the reactants alone, mass of the products alone. Remember, you do this number minus that. Same thing for this. All right. Now for the exciting one. Vinegar and baking soda. I'm going to fold this in half here. Vinegar and baking soda. So I've already found the mass of my equipment, so I don't have to worry about finding that again. Here is my Erlenmeyer flask, because we can see that we're getting carbon dioxide here, and we know that's a gas. So I'm going to have to contain the gas that is being produced. Okay, now it was going to be really boring for you to watch this, but I already went ahead and put the baking soda in here. Now I'm going to find, where's my vinegar? No, I had it somewhere. Okay, let me go find my vinegar real quick. Okay, here's my vinegar. I am going to use this larger graduated cylinder and get 30 milliliters of vinegar. So it's in this weird little container, and that's because it's just a squirt bottle. so I don't have to try and get this, like, do some guesswork to try and get this amount perfect. But there you go. There's my 30 milliliters. I'm going to pour it in there just like so. And then I'm going to stretch the balloon over the Erlenmeyer flask, but I'm not going to let the baking soda fall in. So I'm going to find the mass here. The mass here is 23.1 grams. Now, this is not a perfect setup, and so I know that this balloon is not perfect in capturing all of the gas. So when I look at the results of this, if I see less than a gram that's lost, I'm going to assume that everything here is correct. Okay, it is what it is, y'all. It's just the nature of the beast. Okay, here, let's help this up so we can kind of see. Okay, so I can already feel some of the gas leaking out. Okay, but there you go. So you can see that everything, I tried to contain everything. Now when I put everything back here on the scale, I'll probably see about a gram lost. Yeah, it was 222.5 grams. Okay, now that's not the end of the world. So when you do this, okay, so when you do this and you get this result, you can just say that this was a leaky balloon. That's what we got. Okay, again, your job is to find the mass of the reactants alone and the mass of the products alone. Okay, last one that we're going to do is a glow stick. All right. First, here is my beaker. Now this part is a little finicky because if I don't get the glow stick exactly back in the beaker at the exact right point, what's going to happen is I'm going to probably see like a 0.1 gram loss. Okay. First, I need to find the mass of the equipment alone. My beaker is 114.4 grams. Okay. With the glow stick, has not been cracked yet. When I put it in there, it is 117.8 grams. Okay, what I'm going to do is I'm going to go ahead and break the glow stick here. See, it's starting to glow already. Okay, I'm going to let it kind of sit there and glow for a minute. Let the chemical reaction really start. It's pretty. I like it. Okay, shake it a little bit maybe. There we go. She's bright now. Okay, so this has been going on for a minute. Well, a little less than a minute. But you can clearly see that this is a chemical reaction. You can tell because the energy released here is light. Instead of when we did our hot pack, we had the it heated up. So this one's not heating up. Its energy release is through light. So I'm going to go ahead and put this back here. And I got, well, it says 117.8. Oh, good. That's the right number. I thought I was going to have to adjust it a bunch of times. Okay, so there you go. You're going to find the mass of the reactants alone and the mass of the products alone, doing the same thing with those two numbers as always. All right, y'all. Hope that helped.